Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Physics Feb-March 2024 and this is a paper 42. Alright, now let's start with the first question. So it's a speed time graph and they're asking us to describe the motion between 0.9 minutes to 2.9 minutes. Now if you see that 0.9 minutes is somewhere around here and 2.9 minutes is somewhere around here. What do you see? I think we have uniform motion here because the speed is constant. So your answer should be constant speed or you can mention uniform motion. Alright. So constant speed, let's say we can write here. Then t is equals to 2.9 minutes to 3.5 minutes. Now 2.9 is somewhere around here and 3.9 is somewhere around here. Here, you can directly see that the velocity is decreasing, but it is decreasing at a constant pace. How do I know this? Because the gradient or the slope is constant, right? So, you can just mention here uniform deceleration or you can mention constant deceleration. Then from 3.5 minutes to 4.5 minutes, 3.5 is somewhere here, 4.5 is somewhere here. You can notice that the velocity is 0 here, so you can mention stationary. Alright, now let's move on to the next question. Another bus travels at a speed of this much. The brakes apply a constant force and the bus stops in a distance of this much. All right. This bus has a mass of 18,000 kg. Calculate the kinetic energy. So for kinetic energy, we know that the formula is half into mass times velocity squared. Half into mass is given 18,000. What is the initial velocity? 8.9 whole square. When you solve this, you will get the answer to be nearly 7.1 into 10 to the power 5 joules. Now, calculate the force applied to stop the bus. Now, this is a good question, and I just wanted to visualize it a little bit. See, initially, the bus had some kinetic energy, right? Then the brakes were applied, and then now the bus has kinetic energy final, which is equals to zero. So just think about it. This initial energy completely got converted into the force from the brakes, or we can say work done from the brakes, because you can equate energy with energy, right? You cannot equate kinetic energy with force. You can equate kinetic energy with work done from the force. Make sense? So what we can say here is that initially x amount of energy you had, now all of that is gone, and that is gone because of the brake supply. So there is also a formula in your syllabus guide which mentions work done is equals to change of kinetic energy. Work done will be force into displacement. Change of kinetic energy, see, kinetic energy final minus kinetic energy initial. Final is 0, so let's keep it as 0. Means force into what is the distance traveled? 23 meters. And kinetic energy, initial kinetic energy, you already know 7.1 into 10 to the power 5 joules. Using this, you will get the answer, which is 31,000 newtons. Make sure to mention the unit. Define impulse. Impulse is change of momentum, or you can mention it is the force into time. Alright. Figure 2.1 shows a rocket and its exhaust gases. The exhaust gases are emitted from the rocket with a velocity of this much and at a rate of 2800 kg per second. Now, keep this in mind. This is indirectly telling you the mass per unit second, right? So what is the mass being released per unit second? 2800. It means that if you take the time as 1, your time as 1 second, mass should be 2800. Now, show that the force exerted on the rocket by the exhaust gases is this much. See, we know that force into the time taken is equals to mv minus mu. Initial momentum is 0. M into what is the velocity? Have they given us? Yes, 1400. And let's get rid of this. What is the force you're trying to find out? And now just think about it. If you're putting in the mass as 2800, then the time should be second. So you'll say force into 1 is equals to this, and your force will come out to be nearly 3920000, which you can equate it to 3900 kilonewtons. Round it off to 3900 kilonewtons. All right. Now, calculate the maximum mass that this force can lift from the ground. See, the maximum mass it can lift from the ground would be equals to its own weight, right? So we can directly say force is equals to weight. Then, do we know the force? I think so. So force is equals to m into g, and m can be written as F by g. What is the force? Force is again 3.9 into 10 to the power 6. You just write it in the form of standard form, and g is 9.8. Your answer will come out to be 4 into 10 to the power 5 kg. All right. Now, next question. A car has a weight of 13,000 newtons. The car is supported by four tires, and each tire's area is this much. Now, just think about it. Pressure is equals to force upon area, but this weight is handled by a single tire, or there is a car with four tires. What do you see more often? A car with single tires or four tires? According to me, four tires. So let's use four tires. So force is 13,000, but this will be balanced by 0.016 times 4. So now you just put it in the calculator, your answer will come out to be 2 times 10 to the power 5 pascals. This is what you need to put here. Explain in terms of particles why the air pressure in the tire increases when the car travels along the road. See, what happens is when the car is traveling around along the road, due to friction between tires and road, due to friction between tires and road, the temperature increases. Now again it's the same story again, temperature increases, so the kinetic energy of the particles increases, and if the kinetic energy of particles is increasing, the frequency of collisions increases, so there will be more collisions with walls, leading to a greater force and greater momentum. Greater force, and you can mention greater pressure. All right. Now, a gas cylinder contains helium gas at a pressure of this much, a volume this much. A volume of this much is compressed, is released from the cylinder into the balloons. Each balloon contains this much volume. All right. Which formula should we apply here? Oh, temperature is constant here. Now, keep this in mind. Whenever they mention temperature is constant, it has something to do with pressure volume. So, we apply Boyle's law. It says that PV is equals to constant. So, we can say P1 V1 is equals to P2 V2. P1 you will put it as 2 into 10 to the power 6. V1 is 0.00026. P2 is given 1 into 10 to the power 5 pascals. V2 we are trying to find out. In case you are wondering that the volume of each balloon is given, I agree volume of each balloon is given, but do we know how many balloons have been filled? No. So we take V2 as the total volume of balloons. Alright. Now you just substitute this, your V2 will come out to be 0.52 meter cube. Now just think about it. One balloon can occupy 0.015. How many balloons will occupy 0.52? It's basic maths. Divide. Your answer will come out to be nearly 34 balloons. This is the answer. Define specific heat capacity. It is the energy required to change temperature of 1 kg substance by 1 degree Celsius. A volume of this much oil is heated in a pan, the temperature increases, all right. The density of oil is given, specific heat capacity is given, all right. Calculate the mass. So for mass, we know that density is equals to mass over volume. So mass is equals to density into volume. Do we know the density? I think so, 910. Do we know the volume? I think so, 0.0024. The mass will come out to be 2.2 kg. Now, next part. Calculate the energy required to increase the temperature of oil. Now, it should be clear in your mind after seeing this text. Increase the temperature means you have to use the specific heat capacity formula here. Alright. So, Q is equals to mc delta T. You can also remember this as Q is equals to m cat. A stands for delta. Now, Q is the heat, M is the mass, C is the specific heat capacity, delta T is the change of temperature. Right? This is what we are trying to figure out. Mass is 2.2. Specific heat capacity is given here 2000. And the change of temperature is 180 to 20. 180 to 20 will be 160 degrees Celsius of change. Now, when you do the maths here, your answer will come out to be 7 into 10 to the power 5 joules. This is what you need to put here. Make sure to mention the unit. Calculate the power required to supply the energy calculated. Now, just think about it. Power is equals to energy over time, right? Energy is how much? 7 into 10 to the power 5 joules. Have they given us the time? I think so. Time is given here, 7 minutes. So, 7 times 60, because you need to put the time in seconds and you will get the answer here. Alright, and it will come out to be nearly 1700 watts. Now, let's move on to the next question. It's a directly theoretical theory question. You need to remember the points that application is this, which electromagnetic radiation is used. So for Bluetooth data connection, we know that radio waves are used. I'll just write down the answers here. You need to memorize all these. For optical fibers, infrared is used, IR. For security marking, ultraviolet is used. For sterilizing food and medical equipments, gamma waves are used. Wireless internet, we know that microwaves are used. Alright, state the approximate speed of radio waves in air. We know that all EM waves have the same speed, so this is also EM wave. 3 into 10 to the power 8 meters per second is given here. Now, figure 5.1 shows successive crest of a wave after a plane, alright, through a narrow gap, alright. On figure 5.1, draw 3 successive crests before the wave. So before diffraction, they're asking you, what you need to make sure in this is that the wavelength between the wavefronts stays constant before diffraction and after diffraction. I'll repeat, before it should be same and after it should be same as well. So if this is 4 centimeter, 4 centimeter, the wavefronts you are going to draw should be also 4 centimeter apart. I'm just drawing the rough idea here. You get the point because you need to make sure that they are 4 centimeters apart. So you can draw something like this, use your scale and make sure that this is 4 centimeter, this is also 4 centimeter. Alright, if you measured some other distance here, make sure it is the same here as well. Now, figure 5.2 shows a much wider gap. A plane wave of same wavelength is incident. Alright, a plane wave of same wavelength. Now, just think about it. In this case, the gap size is very large. Alright, and we know that if wavelength is equals to or nearby similar to the gap size, then diffraction happens very well. And if the wavelength is smaller than the gap size, then the diffraction is less, right? So what we need to do here is we need to draw the wavefronts, but we need to draw them in such a way it is showing that less diffraction is there. So let's give it a try. You can draw it like this. Just make sure the wavelength stays the same, and then you can draw a curved pattern like this here. Just make sure that the wavelength stays constant. Alright, the wavelength, the 4 centimeter wavelength we were discussing earlier, you need to make sure it's the same. Here, here, and here. Alright, now question number 6. Figure 6.1 shows a full scale diagram of an object and its image I produced by a converging lens. The lens and its position on the principal axis are not shown. Alright, now this becomes tricky. How do we know? How do we locate the center of lens? For this, I want you to recall one point. We have done 6 cases of lens, convex lenses, placing the object at principal focus, between principal focus and optical center, all those cases. And one rule that we remember is, see, if this is your lens, what you need to do is that if one ray passes like this parallel to the principal axis, so it will always pass through the principal focus like this, right? And if one ray is going through the center of the lens, 1 minute. Hmm. If one ray is going through the center of the lens, it will go undeviated. It will go as it is. This is not the center, but you get my point. All right. So what we need to do here is just join the tip of the object with the tip of the image like this. And here you can mention a line, or you can draw your lens if you want. So they've mentioned a single ray to locate the position of lens. Ray we have drawn here. This is your ray. A line to represent the position. This is the line that I have drawn. So A part is done. Now determine the focal length of the lens by drawing another ray. Now how do we determine the focal length of the lens? First of all, let's complete your lens here. Now the question is, how do you determine the focal length? Remember this point that I told you, that when one ray is going parallel to the principal axis, this is your principal axis. So when it is going parallel to the principal axis and meeting at the center of lens, not exactly the center here, in between here. So it will always pass through the focal length and then it will form the image, right? So what you need to do is just draw a straight ray and just connect it to the image formed. This image formed. So the point where it is passing here, this is your principal focus, and you can just take your scale and measure this distance. That is what you need to put here. All right. Now the object is moved 2 centimeter closer to the lens. So just think about it. See, so nearly this will be the focal length, right? The principal focus. Both sides we have principal focus and they're equidistant. Now if they're moving it 2 centimeter closer, means it will be the last case. Remember the last case where virtual images are formed, virtual rays are used. That case, see, I'll draw it for you. This is the case we are talking about. This is the principal focus, this is the optical center. Now the object is somewhere around here. Let's draw another principal focus here, f1. So one light ray goes straight and then it passes through the principal focus, and one light ray through the center of the lens, it goes like this. Now you can clearly notice that the lines are bending away from each other, so they're not going to meet. So what we do for this is we trace it backwards and then we notice that an image is being formed here. This case, I'm sure all of you have done this already, and this is the case where virtual and upright image is formed. So your answers will be virtual and upright. All right, now draw the circuit symbol for a potential divider. It's a box with an arrow going like this, and just do two connections here. Right? Now, calculate the value of V out when the value of R is this. See, we know the formula for potential divider is V out is equals to V in divided by R total. You might have studied a different form of it, but I use this formula. This is the easiest one. I'll explain. See, V in is the voltage provided by battery. How much is it? 6. R is the resistance of that component. You're trying to find out V out of R here, right? So R you will use as 1000 ohms. And R total will be the total resistance. It can be in series or parallel. In this question, both are in series, and the value of R is also given to you, which is 3000 ohms. So you will directly add the resistance because they are in series. R series is equals to R1 plus R2, right? So 1000 plus 3000, you will get the answer to be 4000. Right? Now when you solve this, your answer will come out to be 3.2. Make sure to mention in two significant figures and not in the exact ratio. So 1.5 volts in decimal form. All right. Now, the value of R is adjusted until the current is given. All right. So they have given you the current 1.7 small n ampere. Now I'm a little bit confused. What is small m? See, small m is always milli, which is 10 to the power negative 3. It can be anything, milligrams, milliliter, anything. It is 10 to the power minus 3 of that quantity, right? And sometimes capital M is also given. This is mega 10 to the power 6. You need to remember this. The examiner will not tell you. In the paper, they will not tell you, just like they have not told here what it means, right? So current is 1.7 into 10 to the power minus 3 amperes. So we know that I is equals to Q by T. I is 1.7 into 10 to the power negative 3. Q you are trying to find out, they're asking you, and time is 300. So just transpose it, 1.7 into 300 into 10 to the power negative 3. Your answer will come out to be 0.51 coulombs. Two significant figures. Now, question number 8. Figure 8.1 shows a wire carrying a large current. Figure 8.2 shows a square card viewed from above. Now, this will be done using the not Fleming's, the right hand thumb rule, where the thumb tells you the direction of current and fingers curl in the direction of magnetic field. I'm sure all of you have studied this. Thumb tells you direction of current and fingers curl in the direction of magnetic field. These symbols you need to understand. Cross means into the plane, into the plane of paper. Just try to visualize, if you're solving on the paper and paper is on your table, so the thumb should be directly pointing towards the paper perpendicularly, and then your fingers will curl, right? So they're asking you to draw three magnetic field lines that indicate the direction of magnetic field. Now, all of you should do this, that thumb should be pointing, let's say if your paper is on the table, so your thumb should be pointing perpendicular to the table downwards, and your fingers will curl something like this. Just give it a try. Your fingers will curl. First of all, let me draw the circles. So your fingers should curl in this direction. When the thumb is downwards and you curl your fingers, it is clockwise direction. So just mention clockwise. All right. Now, the next part, the current in the wire increases and the direction of current is reversed. See, when you're increasing the current in the wire, it directly says that magnetic field will increase. The strength or the power of magnetic field will increase. But now you're also reversing the direction of current. Think about it. Earlier we were pointing our thumb downwards and then the fingers were curling in clockwise direction. Now the thumb is upwards. Imagine your thumb is pointing towards the ceiling. You get my point, right? When you give a thumbs up to someone. So that thumb is pointing upwards and the fingers are curling in the direction of anti-clockwise. You can just say that direction will reverse anti-clockwise. All right. Now, electricity is transmitted at high voltage. Explain why high voltage increases the efficiency of transmission even with thinner wires. Now, this is a good question. I want you to understand this, that power loss is equals to I squared R. Now, when you're using thinner wires, we know that resistance is inversely proportional to area. So when you're using a lower area, resistance will be more, right? Now, just think about it. If you're using a greater amount of resistance in the wires, the current will decrease, right? Now just think about it. If you consider R to be constant, you're just using a wire with high resistance, fine, but the resistance is constant, all right? So resistance is constant, your power loss is directly proportional to I square, and now you're telling me that resistance we are using very high, it is constant, but it is very high. So the current should be lesser, and if the current is lesser, power loss will be less as well. All right. Now another formula, power is equals to V into I. So just think about this. What do we aim for? Let's say I am the electricity generator and I have to supply electricity to homes. Do I aim for that whatever electricity I'm generating, the same electricity without any loss goes to the houses in the X amount, whatever they require? Or do I want that if I'm creating 100, 50 of it gets lost, gets wasted, and 50% goes to homes? What do we strive for? We strive that whatever we have produced, we utilize it in some way or the other, minimizing the loss, right? We want least loss possible. So we want power to be nearly constant. The power you are generating and supplying, we want it to be nearly constant. So power is equals to V into I. Now you can think of it in two ways. You can increase the voltage, decrease the current, or increase the current, decrease the voltage to maintain the same power, right? Imagine this is 6. So 2 times 3 is also 6. Let me put 3 here. 3 times 2 is also 6, and 2 times 3 is also 6, right? It just depends which method are you preferring. Currently, we use this high voltage and low current because, as we discussed here in the formula, if lower current is used, then power loss will be less. This is me trying to explain the concept to you. We will discuss what the answer you need to write, but just try to understand it first of all. If you want power to stay constant, you can have two methods: increase the voltage, decrease the current, or increase the current, decrease the voltage. We prefer the former one, more voltage, less current, because when you have less current, power loss will also be less. All right, I think you got it now. Now, what is the answer do we need to put? This is the question. What answer should we put here? I got the concept, but what should I put here? Now, the way you have to frame your answer is, just give me a minute, I'll erase all this. So you can first of all mention power loss is equals to I square R. Then you can mention high voltage allows low current at same power, right? Then you can also mention that you're using thin wires result in high resistance. See, we tried to connect it here, no? That thin wires result in higher resistance. If high resistance is there, current will be low. Then you apply P is equals to I square R. If the current is low, power loss will be low as well. I think it makes sense to you now. All right. Now, question number 9. It's a question on atomic physics. Very simple topic. See, an experiment directs alpha particles. What are alpha particles? These are helium nucleus with a charge of +2 at a very thin sheet of gold foil. Okay, most of the alpha particles pass through the thin foil. All right, state the conclusion. See, if most of them are passing straight through, you can just mention that most of the space is empty, most of the atom is empty. Now, some of the alpha particles are deflected through small angles, through angles less than 90 degrees, and few are deflected through 180 degrees. State and explain two conclusions about the nuclei of atoms from this observation. First of all, you can mention that only a few are getting deflected. So you can just mention that the nucleus is very small. Nucleus is very small because nucleus is positive charge, right? Nucleus contains protons, and only a little bit number of particles are getting repelled. So you can just mention in the explanation, not a lot of alpha particles are getting deviated. Alright, you get my point. In conclusion too, you can just mention that nucleus is positively charged. This is the conclusion we draw from this experiment. From this experiment, we got to know that nucleus is positive in charge. So nucleus is positively charged. This is the conclusion. Now, what supports this? Because alpha particles are positive charge, just like I mentioned on the top, it is helium's nucleus with two protons. So, alpha particles are positively charged and the force is repulsive. This is what you need to mention here. All right. Now, a source contains a radioactive isotope of strontium. This isotope decays by emission of beta particles. The half-life of this isotope is this much. All right. State the change in the nucleus which occurs. Now, there's a one straight point in beta emission that we always study, that one neutron converts to a proton and at the same time releases a high speed electron, which is the beta particle. This is the same thing in form of statement which you need to mention here. What you can write is that in the nucleus of a in the nucleus, a neutron is changed into a proton and electron is emitted, which is the high speed beta particle. All right. Now let's do the half-life question. The initial mass of this isotope is 25 micrograms. Calculate the mass of the strontium that decays in 87 years. All right. So I know that a lot of students use ratios for this and it saves you time, but sometimes we end up making mistakes in those. We forget subtracting something or adding something depending on the question. So I'll give you one simple way to solve this. It will take a little bit more time, but your accuracy will be more. Chances of error will be less. All right. What do we need to do here? See, the initial mass is how much? 25 micrograms. All right. The first half life is 29 years. All right. So in the first half life, after 29 years, 12.5 must be decayed and 12.5 must be remaining. All right. On the left, I'm writing decayed and on the right, I'm writing remaining. Now, after another 29 years, from this remaining, 6.25 must have decayed and 6.25 must be remaining. For how many years do we need to find this? For 87 years, we need to find it. And you know that 87 over 29 is 3. So we need to do 3 half lives. Now, another 29 years, the remaining 6.25 will decay into half, which is 6.25 divided by 2, which is 3.125. This has decayed, and how much is remaining? 3.125 is still remaining after these 3 years. Now, calculate the mass of strontium that decays in 87 years. In the first half life, this much decayed. In the second half life, this much decayed. In the third half life, this much decayed. Now, when you add all this, 12.5 plus 6.25 plus 3.125, the answer is 21.875. You can round it off to two significant figures. 22 is the answer. All right. If you want me to explain again, I will explain this again to you. But if you use this method, chances of errors will be very less because you clearly know how much is being decayed and how much is being remaining. So, how we did this? 25 micrograms for the first half life, 29 years, 20, 12.5 decayed and 12.5 is remaining. Then next half life, another 29 years. Out of this, 6.25 decayed and 6.25 is remaining. In the next half life, 29 years, 3.125 decayed and 3.125 is remaining. Now just look at the question they're asking you. Calculate the mass of strontium that decayed in 87 years. So 12.5 decayed first, then 6.25, then 3.12. You add it up, your answer will come out to be 22 micrograms. Alright? Now, starting with question number 10, this is a space physics question, and they're asking us state the position of moon where an observer on Earth sees. So this is the one of those points which you need to remember the figure. They can directly ask you anything from it. Now they're asking for quarter moon. If you look at this figure here, quarter moon is at the top and at the bottom, right? So which point would that be? A and E. So you need to just mention A and E there. All right. Now there is a full moon. Now, if you check the figure, full moon is at the extreme left in the middle. So it should be point G. So point G. State and approximate time taken for the moon to orbit the earth. Moon orbits the earth in nearly a month. So the answer should be 1 month. Now, the average distance is this much. Calculate the orbital speed. We know that orbital speed is equals to 2 pi into r by time. 2 pi into r will be 1.5 into 10 to the power 8 kilometers. Time you should take in hours only. And in 1 year, the time is 365 into 24 hours, right? 365 days, each day has 24 hours. When you solve this, you'll get the answer to be nearly 500 seconds. Wait, not 500 seconds. This is average orbital speed. So the answer will come out to be 11,000. You just need to put it in the calculator. Your answer will come out to be this. All right. Now, the speed of light is given. Calculate the time taken now. All right. The speed of light is, let's apply the formula speed is equal to distance over time. Speed is 3 into 10 to the power 8. Distance, I think we already know, 1.5 into 10 to the power 8. Is it 8? Yes, it is 8, but just make sure it's given in meters here. So you will have to say 1.5 into 10 to the power 8 kilometers into 10 to the power 3. So it will turn up to be 10 to the power 11 meters, right? Just write it here and t. You just substitute it and solve the formula. Your answer will come out to be 500 seconds. Now, this is a space physics question again. State the condition required for a protostar to become a stable star. You know that a stable star is when net force is 0. So you can just mention that when outward forces due to nuclear explosion, not nuclear explosion, nuclear fusion, are balanced by. I just watched Oppenheimer recently, so that is when nuclear explosion came out. But it is nuclear fusion are balanced by inward forces due to gravity. Define Hubble's constant. We know that Hubble's constant, see, the formula is H naught is equals to V over D, right? If you want to define it, you can define it in terms of the ratio. You can just mention that it is the ratio of speed of galaxy to distance away from observer. Everything is moving away from us. The universe is expanding, right? So away from observer. The current estimate for Hubble's constant is this much. State the equation which gives an estimate for age of universe. Now, age of universe means time, and you know that Hubble's constant is second inverse. Just look at the unit here. It is per second. So you just mention that 1 upon h naught will give you the time, right? Calculate and estimate for the age of universe. Now, what you need to do here is just do 1 upon h naught, and Hubble's constant value is given to you. You just solve it. How do you solve it? See, some students also have problem solving these kind of equations. What you can do is transpose the exponent above and it will turn to positive 2.2. Then just take a 10 out of it, divide by 2.2 and keep this as 10 into 10 to the power 17. Now you can solve this, put it in the calculator, 10 over 2.2. It will come out to be nearly 4.5. Then just write the exponent as it is. Alright, and second is always given here. So no need to mention the unit.